Hello, this is John from caveofprogramming.com, and this is a tutorial on queues in Java. So I'm in Eclipse here and I've got a main method set up already, and so let's take a look at what a queue actually is, and I'll have a comment here. And imagine you've got a queue of people in everyday life. So let's imagine that this string of O's is a queue of people. In normal parlance, we say that people enter the queue at the end of the queue and they leave at the front of the queue. So this is the front and this is the end of the queue. In programming lingo, the front of the queue is called the head. So items will leave at the head of the queue, and the end of the queue is called the tail. So we add items to the tail of the queue. And a queue is a first in, first out structure, FIFO, meaning that the first item that you remove from a queue will be the first item that you added. And in general, the sooner you enter a queue, the quicker you can leave it. And so, like, when you add an item to the queue, you're always adding to the tail, and then you're removing to the head, and you're removing from the head. And the items that you remove from the head are going to be the items that you added the earliest. So let's take a look at an example. And if you go to Google and you search for Java and your versions, like Java 7 in my case, and you search for queue, you get this quite nice API document. And if you look at here, look at all known implementing classes, you can see that the kind of standard Java classes that implement the queue interface, and one of them is linked list. So everything that I'm about to say in this tutorial, basically, well, not everything, but much of it can apply to linked list as well, and you'll see what I mean in a minute. But I'm actually going to show you a different class in this tutorial, a different class that implements the queue interface, which is array blocking queue. Because the thing about a queue is, just like in real life, a queue can have a maximum size to it. So often in real life, queues can be endless, as you well know. But like it's possible, or you could conceive, that a queue could have a fixed limit. Like maybe you can only fit so many people inside the shop, so the queue has a limit to how many people can actually be in that queue. And of course you need ways of dealing with situations if you try to add more items to the queue than can be in it. So let's take a practical example here. Let's look at array blocking queue. So I'm going to actually declare a variable here of the queue interface type, and let's make this a queue of integer values. And I'll call this Q1, and I'll set Q1 equal to new array blocking queue. And I could use linked list here, or any one of the other implementing classes. So that's an array blocking queue of integers. And array blocking queue, and the reason that I'm actually choosing it here instead of linked list is that, unlike linked list, which has a potentially infinite size, array blocking queue has like a fixed size to it. So you can say here, okay, I want a queue that has maximum 3 items in, although of course usually probably it would be more than 3 items that you'd want to have in your queue. And I'll add the input there with Control Shift and O. So this is a queue. It's a first in first out structure with a maximum of 3 items in it. And queues have like the queue interface, it defines 2 separate sets of methods for working with the queue. And if you look at the API document, you can find this table here that shows you the 2 sets of methods. So for adding elements, we've got add. For removing them and returning them, we've got remove. And we've also got element, which allows you to look at the head of the queue. And it's worth mentioning that you can just iterate through a queue. So I could use a for loop here, just like we did earlier in this series of tutorials. But I'll leave that for a minute. And let's take a look first at add, remove an element. And these methods, add, remove an element, throw exceptions if you try to do something that doesn't make sense. So let's add some values to the queue. So I'll say q1.add, and let's add the value 10. And I'll just copy that, and I'll try to add try to add 4 items. So we've got a queue that has a maximum size of 3, and I'm trying to add 4 items to it. And if I run that now, we'll get this illegal state exception. But notice that add didn't force me to put a try catch block in. So this is an unchecked exception, a runtime exception. We're not forced to handle it, but we can handle it nevertheless. So if I put try here, I'll just do control space to autocomplete that, and I'll change this to a illegal state exception, and I'll put my 4th add in there like that. And let's say here sysout try to add too many items to the queue. And if I run that, it's going to catch my exception and say that tried to add too many items there. So add will throw an exception if you try to add more than the capacity of the queue, but you won't see this exception with add if you use a linked list, because a linked list is not bounded. You can just keep adding items to it until your computer finally grinds to a halt. So that's why I chose array blocking queue, because I wanted to show you this happening. And of course, if you want to see what's in your queue, you can just use like a for loop. So I could say here for integer, let's say val, or value in q1, and we could just say sysout let's have q value and plus q plus value here. So if I run that now, it's just a normal for each loop, and I can see what's in my loop, in my queue. Okay, so that's add, and of course there's also remove. So I can say let's say value, I think I can declare another value here, or is that still in scope? I think it is. So if I say here integer value equals q1.remove, oh yeah, I wasn't actually sure whether I could have another value here, but I guess the scope of this is restricted to these brackets here, so I can. So if you call remove, it removes the head of the queue and returns it. Now the head of the queue here is first item we added, it's 10. So let's take a look here. In fact, I'll declare value here, and then separately I'll call remove, and I'll put here a sysout removed from queue, and let's say plus value. So if I run that now, I get removed from queue 10, because 10 was the first value I added. And I can do that, of course, over and over again. So I've got 3 items in the queue, and let's remove all 3. In fact, for simplicity here, I'll just put the remove directly in there, rather than having this separate variable. And then I'll just copy this and remove. I'll try to remove 4 items, so 1 more item than there is in the queue. And you can guess now it's going to throw an exception, a no such element exception. So if I want to catch the possibility of that happening, and I'm not forced to catch this, I'm not forced to put a try catch block around it, but I can do, then I can catch no such element exception. And let's say here sysout tried to remove too many items from queue. And if I run that, that exception will be thrown. And finally, we've got the element method. So if I say here, let's look up here. So I could use element to see the head of the queue. So I could say sysout head of queue is, and there I could use the element method q1.element. And if I run that, it's going to tell me the head of the queue up here. So head of the queue is 10, that's the first item in the queue. And similarly, if I try to call element when there isn't a head of the queue, then it's going to throw a no such element exception. So let's just put a comment here. Throws no such element exception, no items in queue yet. Okay, so that's one set of methods for working with queues, and there is another set as well. So if we look at the API document here, you've also got offer, poll and peak. And let's take a example. So I'm going to just put a big comment in here, and let's have a second queue like this, and I'll copy this and paste this in, and let's try to do the same thing again basically. So I want to pretty much do all the same stuff that I've done before, I guess. Let's add a bunch of items here. So I've got 3 items in this queue again, and let's make it 2 just to make it slightly simpler. And so I'll try to add 3 items to a queue that has 2 items in it, and let's then just view the contents of the queue, and I'm going to change this here to Q2. So we've got a second queue, and I'll iterate through Q2. So now if I run this, there's let's see, we've got a no such element exception because I'm using add, but let's change this to offer. So offer, offer and offer, and if I run this now, you see it hasn't added this last item here, queue value. Let's say Q2 value. This is my second queue, but it hasn't thrown an exception either. And in fact, what offer does is it just returns false if it can't add the item. So I can say here, if Q2 dot offer is false, then let's say sysout offer failed to add third item, and we'll see that that's coming out here. And it's the same with remove. Like if you try to remove, sorry, not with remove, with poll. So you can use poll to attempt to remove items from the queue. I can say sysout Q2 poll, and let's say in here plus Q2 dot poll. So poll actually removes items, and if I run this here, we'll get the head of the queue, which is 10. But if I've only got 2 items in the queue, so if I call it 3 times, then what will happen is it will return null the 3rd time. So poll is just like remove, except that instead of throwing an exception, it returns null. And offer is just like add, except that if it can't add the item, it just returns false. And it's the same finally with peak. And if we try to peak at the head of the queue, and there's nothing there, then it will return null instead of actually giving me the item. So let's say here Q2 peak, and let's add here Q2.peak, and if I run that, then peak, you'll see, is saying null. But later on, when I've added items to it, this will get me the head of the queue. So if I run it down here, then I've got the head of the queue down here somewhere. Where are we? There we go. So the first one was null before I added items, and the second one 10. So quite long-winded business this, but basically that's all there is to it. 2 sets of equivalent methods, and one throws exceptions, the other has special return values for if it can't work. And as I say, you can also, if you want an unbounded queue, because because a queue can be bounded or unbounded. You could use, for example, linked list, and a bounded queue would be array blocking queue, for example. Now there's just one more thing that I want to say about queues here, and in fact this is about blocking queues, because if we look here at the queue interface, you can find that it's got a sub-interface called blocking queue. And if you look at the blocking queue interface, then it's got another set of methods. It's got two. So it's got ones that time out here. You can supply, so if you try to add a value and you can't add it, then you've got these methods put and take. And put will just hang your program, suspend your program until the space becomes free in the queue and you can add the value. Whereas take will, if you try to take an item, in other words remove it and return it from a queue that has no items in it, then again it will just suspend your program thread until items become available in that queue. And then you've got offer and poll that take these timeout units, so you can wait and see for a certain length of time if an item becomes available or not. And I just mention that here because if you go on to do any kind of multi-threading stuff, and you can find, if you go to, let me just do a quick plug for my website here. If you go to www.caveofprogramming.com, you can find a whole bunch of lots and lots of free tutorials there, and also some premium paid tutorials on like Android web programming and swing programming. And among other things, you can find a series of tutorials on multi-threading, and in there we go into how you can have multiple threads of code running at the same time. These are free tutorials, by the way. And array and blocking queues, such as array blocking queue, are very useful for that, because you can have one thread adding items to your queue and another thread trying to remove items, and if the other thread can't remove items, it will just wait until items become available. So it's very, very useful. Queues are very, very useful in multi-threading, especially array blocking queue. But you can, of course, you can use linked list or even array blocking queue from single-threaded code like this if you want. Okay, so that's it for this tutorial, and I'm not sure whether there are going to be more items in this series of tutorials on collections, but probably we'll go on to look at iterable and iterators, because those are very, very relevant to working with collections. So join me again next time, because I've just decided, I will add more tutorials to this series because this is useful stuff to know, and we'll look at iterators and iterable. And until next time, happy coding.